that night, Kyoko won't say a word to me.
Hi, in this first episode of Engin-Hearing, we will discuss and introduce some pioneering methods that inspire the actual state-of-the-art to solve tasks as the one of source identifications. Nowadays, indeed, the use and production of multimedia data becomes as massive as the threats that came from them. It is then important to develop methodologies and techniques aimed at solve tasks as the one of source identification to prove the integrity of our multimedia data in order to protect ourselves from malicious intents, use this data as proof in courtroom cases, and distinguish real from fake news. But how can we do that? Luckily, the device we are all using nowadays introduces some sort of traces or artifacts during their camera acquisition process. This one indeed may occur on different levels, may be introduced by the sensor or by other parts, such as the color filter array or the in-camera post-processing. Today, as said during the introduction, we will just give an historical overview of the method that inspired the actual state-of-the-art. But we will have the chance in the next episode to explore what's new came out. Before starting presenting the method, however, I would like to distinguish method for brand identification, and so method that study unique feature introduced by the brand of certain camera model, and so that are unique for that brand, and methods for source identification, which study feature introduced more general by all the brands, but that are still unique due to some factor during the manufacturing process, so on and so forth. As you may understand, however, method for source identification generalize quite well even for method of brand identification. And for this reason, when we will talk about the method for brand identification, we will move quite fastly. The paper I will cite then for this first branch is the one of Karasi et al. He selects 34 most relevant features introduced during the camera acquisition process between colors, quality factor, and wavelet coefficients and feed them to a multi-class classifier, in his case a support vector machines. He actually obtained relevant results in terms of accuracy on moderate compressions device, but the main cons of this method is that using such an amount of feature is really difficult to distinguish which one really contribute in terms of classification. Concluding, brand identification can also be accomplished studying the different effects that in-camera post-processing have on their media. Once for all, radial correction post-processing that are aimed at solve the distortion introduced to the lens of our device, similar to the one introduced by the lens of a GoPro every time that we take a video or an image when we use this device. However, not being this correction really unique, are less reliable with respect to the other methods. For source identification instead, we have three main contributors. The first one is fixed pass-through noise by Kurosawa, which are dark currents revealed in presence of low exposure or no exposure of the sensor. They present themselves as additive noise and for this reason are quite easy to be removed with some post-processing, which has an impact on their reliability. The second method is sensor dust by Derek, which actually work only on device in which we can dismount the lens, and so the dust can fall over the sensor and map in some unique way due to electromagnetic fields of this one. And the last one, and the one that survived till our days, is actually PRU, a scant residual introduced by the sensor itself and due to the manufacturing process this one underwent during the production of the camera of the device in which it was mounted. In the end, PRU can be seen as a source of noise that is unique because introduced by the sensor of our device and that we can extract by filtering out from an image or a video taken with a certain device. The chain of processing to filtering out is apply a wavelet denoiser, followed by a zero meaning by row and columns, and then applying a Wiener filter in the FT domain. Once extracted, the PRU can be compared with other PRU that we suppose came from the same device in order to understand their provenance, or if we have a set of images that we really know came from the same device, we can extract the PRU from them and average together in order to obtain a consistent signal called camera fingerprint. And then, of course, we can always use it to accomplish the task of source identification. For today is everything. But we will have the chance in the next episode to better discuss and talk about PRU, how it's employed nowadays, and why it's still a valid ally in task of source identification and tampering detection. Another question that we will try to answer is if it is always reliable. And, well, Not always. Due to anti-forensic post-processing and so phenomena that in some way alterate or distort the PRU, we cannot always imply it reliably straightforwardly. What we can do instead is develop algorithms robust to anti-forensics and that in some way are able to resynchronize it with respect to the ground truth with which we want to compare it. Finally, I would like to remind you that all the references at the site are in the description below if you would like to read it yourself, and we catch in the next video. Bye.